Okay, here we go again, lesson 3.6. Now in this lesson we're going to continue with our division of decimals. And this time what's going to happen is we're going to be dividing something which has what's called leading zeros in it. Okay, so first thing, before we can do anything about this, we have to talk about what are called equivalent decimals. So I'm going to give you 1.5 and 1.50. The question I want to ask you is, are they any different? Well, you should know from before that no, they're not. These are what are called equivalent decimals. They both have 5/10. If you look down here, you can see here's 1.5, you'll see 5/10. And if you go down here, this one also has 5/10. There's no zeros here in the hundredths, and there's a zero here in the hundreds, which means there's none of these and none of these, which means in reality, 1.5 and 1.50 are the same thing. 1.5 and 1.50, we refer to those as equivalent decimals. Now, could you name more equivalent decimals which are equivalent to 1.5? All you really need to do is start adding zeros to the end. And you can add as many zeros to the end as you wish. So this gives you all equivalent decimals, and these are all equivalent to 1.5. Now the word equivalent means equal. They're the same. Okay, now name 3 equivalent decimals for each one. So I'd like you to pause the recording and do 2.3 and this one and that one. All right, so 3 equivalent decimals for 2.3. You can add as 1 0, add 2, add 3, add 4, add 5, etc. 141.250, 141.2500, etc. And of course, 14.0, which is 140 thousandths, 140 10 thousandths, 14 100 thousandths, etc. like that. So why is this important? Sometimes when you divide, you can't get a remainder of 0 at first. You have to add zeros to the end of the dividend so you can continue dividing. Now we've done a little bit of this before, we talked about it, but we've never actually done the dividing part. You've always had to bring down decimals, but they've always been whole numbers. So let's take a look at this one here. What is the quotient of 71.4 divided by 4? Now remember, what we're doing here is we're dividing by 4. So remember, inside, out. Okay, so this is inside the box, this is outside the box. All right, now, after you bring down the 4, the last 4, you're going to start adding zeros to the end here and start bringing down the zeros until we get to the end of the division. So I'm going to zoom in, and we'll do this question. All right, so how many times does 4 go into 7? Well, we know that goes into 1, and that gives you 4. All right, and 7 take away 4 is 3. Bring down the 1. How many times does 4 go into 31? That's 7 times, because 4 times 7 is 28. Subtract 31, take away 28, and you get a 3. Now you can bring down the 4. 4 goes into 34, 8 times, that's 32. Subtract these, you now have a 2. And now you can bring down the 0. 4 goes into 20, 5 times, and it's exactly 20, which means when you subtract it, you get 0. So you can see here, we added the 0 here to the end to make sure we could continue the division, because up here you notice there was no 0 to begin with. You added the 0 to continue the dividing until we can get to 0 here at the final end. All right? Let's take a look at another one. 2.37. I'm going to add another 0 here. Now, you can add them before or during. Usually we add them during, okay? But let's start out. How many times does 6 go into 2? Well, it doesn't go in at all, all right? And if you want, you can just go over and now include the 3, but don't forget to put the decimal up. So how many times does 6 go into 23? That is 3 times, and that 6 times 3 is 18. Subtract it, you get 50. You get a 5. Bring down the 7. All right. How many times does 6 go into 57? 54. That would be 9 times. 6 times 9 being 54. Subtract that, and you're going to get a 3. All right. Bring down the next digit, which happens to be a 0. Now, how many times does 6 go into 30? 6 goes into 30, exactly 30, and that's 5 times. So we end up getting 30 take away 30, which is 0, which means we're finished. And the answer is 395 thousandths. Okay? Now, it's time for you to try one. Okay? So by adding, zoom up so you can see everything. So by adding to the end, for adding zeros to the end of the dividend, you can continue the dividing until you get a remainder of 0. All right, so I want you to pause this one And I'd like you, or pause the recording, and I'd like you to do 15.97 divided by 5. Okay. Now, the next step is let's take a look. I'll zoom back in. All right, here we go. How many times does 5 go into 15? Sorry, into 1. It doesn't go in. So consider the 15. 5 goes into 15 3 times, and that's exactly 15. So when you subtract it, you get 0. Bring down the 9. 5 goes into 9 one time. Click. There we go. Put your decimal up. Sorry, 5 goes into 9 one time, and that's a 5. So when you subtract it, you're going to get 4. And then you can bring down the 7. 5 goes into 47 9 times, and that's 45. Subtract it, you get 2. Now, we're still not done. We bring down a 0. 5 goes into 20, exactly 4 times. That's 20, and that gives you a 0 as your remainder. Now, if you take a look here, I guess you can't make that all stay on there. In all the examples we've counted so far, the answers have always ended up in a remainder of 0. These are called exact quotients, which means it's an exact number. Simple example of an exact number would be like 6 divided by 2 giving you 3. The answer is exactly 3. Now sometimes what happens though is you get a number which is not exact, and that means that you can't divide it and get to a 0 because it starts to do some other things. So this is what I would like you to do. I'd like you to take and go and divide 3 into 20. Put up your decimal and then go as long as you think you should. All right, so pause the recording and do this division. Okay. Now that you've done this, you should realize that it starts to have a problem down here and it doesn't end. So let's take a look. 3 goes into 2. It doesn't go in at all. So let's take a look at the 20. 3 goes into 20 6 times. And that is 18. But when you subtract that, you get a 2. Bring down the 0. Put your decimal up. 3 goes into 20 18 times. That's another 6. So now we have 6 decimal 6. Subtract, you get another 2. Bring down a 0. 3 goes into 20 6 times. And that's 18. Subtract it, you get another 2. And every time I bring down a 0, it goes to 20. 18 will go in, and I'll get a 2. Bring down another 0, it goes to 20. This is referred to as a repeating decimal. This would actually be 6.666, and this here goes on forever. It never stops. You can keep dividing until you run out of life for paper, and it's just going to keep going. All right? So we have to have a way to deal with something like this, and we do. Okay? Let's take my view back here so it's easier to work with. This question, 20 divided by 3, gives us a quotient, so that's an answer to a divide question, that never ends. This is an approximate quotient. Remember, 6 divided by 3 was 2. That was an exact answer. This one's not exact. Okay, you can never write this down because you'd have to be able to put down the 6's forever, and you can't do that. That's why it's an approximate. This 6.666666 goes on forever. Now, how do we do this? Well, there's several rules that we can use. You can round to the nearest hundredth, which would be 6.67. Remember that this is your cutoff right here, all right? And this 6 here causes this 6 to go up. Oh, I guess I'm one too far to the right here. Let's go back over here. Okay, so there's your cutoff there. This 6 here is 5 or greater, causing that to become 6.67. That's rounded to the nearest hundredth. Now we have some rules that we use, and you're going to have to learn these rules. These are the general 4 rules you need for dividing. So first off, if you're dividing whole numbers without decimals, you always round to the nearest hundredth, just like we did right here. These were whole numbers, 20 divided by 3, so it would go to 2 decimal places. Now note, in order to get the 7 to find out what happens to the second one, you've got to go at least 3 decimals, so you could, 3 digits, so you can round back to 2 digits. Now, if you're not told, if you're told what to do, you round to that level. So if you're told to divide to the nearest tenth, that's 1 decimal place. If you're told to divide to the nearest thousandth, that's 3 decimal places. So if you're told, you do it. If the dividend has a decimal, now the dividend is the inside number, you have to round to what that number is. So for example, if the dividend has 3 digits behind to the right of the decimal, then you have to have an answer that has 3 digits to the right of the decimal. Now, money is always quite simple. Money is always 2 decimal places, so you have to round to the nearest hundredth. So let's look at a few examples here and just see if you can figure out what you round them to. Okay, so I've got 1 decimal 8 divided by 7, and here's where 257142857. I'd like you to put the decimal in here, and in here, and in here, and in here, and round it off accordingly, okay? So you can use your calculator if you have to, I guess, but I'd like you to take a look at this and do these. So pause the recording and place the decimal in place. Okay, 1.7. Now, this is the dividend. It's got 1 decimal in it. So that means I have to have 1 decimal in my answer. Well, 1.8 divided by 7 is 0.257, and that means that 5 causes the 2 to go up, so this becomes 0.3. The dividend is in the nearest tenth, so my answer has to be the nearest tenth. This one, my dividend is the nearest hundredth. So 2.65, that would be 0.29 because the 4 does not cause the 9 to increase. So your answer is 0.29, and the reason the dividend is the nearest hundredth. Now, 32 divided by 7, that's going to be 4.5714, but when you round it, you're going to get 4.57. The reason for that is these are whole numbers. Because they're whole numbers, you go to 2 decimal places. All right? This dividend has 1 digit to the right of the decimal, which means your answer must have 1 digit to the right of the decimal. 26 divided by 3 is around 8, so it should be 8.9 with 1 decimal, so your answer should be 8.9. And finally, the last one, 8.663. 8 divided by 7 is 1, so my decimal is going to go between the 1 and the 2. This has 3 digits to the right of the decimal. That means my answer has got to have 3 digits to the right of the decimal also. Now, the one thing that's not included here, which I noticed, is there's no money here. Now, if you had money, it would be done to the nearest hundredth also. Okay, so let's take a look at some examples here. Now, remember when you're doing this, you should always look at the question first and find out how many times you have to divide by 7. If you just keep going, you can actually, fill pages, and you're doing a lot of extra work. Now, if you take a look here, this number is 9.635. So I've got 635 here. I've got 1, 2, 3. So I've got to have 3 in my answer. Now, in order to find out whether the 5 has been changed, the third digit to the right of the decimal has to be increased or not, I'm going to have to go 1 decimal further. So I've got to divide 4 decimal places. So let's take a look at this, and we'll go through it. Actually, why don't you just pause the recording and you do it, and then we'll continue. All right. So 7 into 9 goes 1 time. Okay. And that would give you, these aren't, just give me a second here. I'm going to do a little bit of magic. For some reason it got past me without doing it. All right, so let's go. All right. Oops, sorry. Go back up. So 7 goes into 9 1 time. All right. And 7 times 1 is 7. So that means that 9 take away 7 gives me a 2. And now I put my decimal up, and I bring down my 6. Now 7 goes into 26 3 times. See, the decimal's up now. And that would mean you've got 7 times 3 is 21. So it's 26 take away 21 is 5. Bring down the 3. Now, I've got the 3 brought down to here. Now the next step is, how many times does 7 go into 53? Well, 7 goes into 53 9 times, because 7 times 7 is, oops, missed that one. There we go. Can we get it? There it is. 7 times 7 is 49. And 53 take away 49 is 4. And now I can bring down the 5. All right. Now the next step, 7 goes into 45 6 times, and that's 42. And 45 take away 42 is 3. And now I can bring down a 0 because I'm not done. All right. Now 7, let's see if I can make this work. 7 goes into 30 4 times, because 7 times 4, oh come on, is 28. 30 take away 28 is 2, and now I can bring down another 0. All right. So now I'm at the situation where I've got how many times does 7 go into 20? And that's twice right here, and that ends up giving me 20 take away 14, which is 6. Now I can stop here because if you notice I've got 1, 2, 3 digits to the right, and I've got 1, 2, 3 digits to the right. So what I need to do is I need to cut off right here. And does this 4 cause that 6 to go up? And because this 4 is not 5 or greater, that 6 stays the same. So I didn't even have to divide the last part here with the 2. I could have just left it after the 4. So the 4 does not cause the 6 to change. So my final answer is going to be 1.376. Okay? So it's important that you keep track of what you have to divide to, or you can make yourself do a lot of extra work. All right, so here we go. Bob divided a 1.928 liter pop bottle of pop among 7 people. How much did each person get? Okay, so here's our dividing. Oh gosh, okay, good. I put the right answer number in here. I copied this down wrong. That doesn't matter. This is supposed to be an 8 here, but it's fixed. It's okay. All right, so just worry over that. Okay, so 7 into 1.928. Now notice 1, 2, 3 decimals to the right, or digits to the right of the decimal, which means my final answer has got to have 3. So it means I've got to get to the 4th one to know if I can change the last digit up here. So let's go through this. 7 does not go into 1, so let's go over and include the 9. All right, that's a 0 there. Now, put your decimal up, and I've now got 19. 7 goes into 19 2 times, that's a 14. And when I take 19, take away 14, I end up getting a 5. Now I can bring down the 2, which is what I did right there. All right. Now, 7 goes into 52, 7 times. 7 times 7 is 49. All right, and 52 take away 49 is a 3. This is kind of shifted too far to the left. And then I can bring down the 8 to go with my 3. 7 goes into 38 5 times. 7 times 5 is 35. All right, 38 take away 5 is 3. And now I can bring down another 0. All right, notice everything's shifted wrong. I should correct that next year. So anyway, the next step is how many times does 7 go into 3? Now you notice I've got 3 here. I need to only have, I have to have the 4th one. So I've only got to do one more step. So 7 goes into 30 4 times, and that's 28. When I subtract that, I get a 2. Now I don't have to go any further because I have 3 in my dividend here, which means I have to have 3 in my answer here. I need the 4th digit to tell me whether the 4 will change to 5 because my cutoff is right here. Okay, 0.275. I need to know whether this is 0.275 or 0.276. The 4 is not 5 or greater, so this stays as a 5. So my final answer is going to be 0.275. Okay, let's take a look at this one. 3 friends shared a rented movie for $4.28. Purchased 3 bags of chips for $1.26 each and 3 bottles of pop for $1.89. They shared the cost equally, so how much did each person pay? Well, the first thing you need to do is to find the total cost. Well, I've kind of cheated there because you look down, you'll see the total cost down below. But you have to find the total cost, and that would be adding everything up. Now you notice they got the $4.28 for the movie. There was 3 bags of chips at $1.26, so 1, 2, 3. And then you have $1.89 3 times 1, 2, 3. You add that all up, you get $13.73. Now, if you wanted to, you could shorten this up and go 4.28 plus 3 times this and 3 times that, which is what I did right here. You still get 13.78. Okay? All right, so we now have a total of 13.73. Okay? Next step, we need to find out how much each person pays. Now, we have 3 friends, and we have 13.73, so I've got to divide 13.73 up into the 3 friends. We know what each person pays. So what I'm going to do here is I'm going to, again, grab my view, close in a little bit, make the clicking a little bit easier. So now, how many times does 3 go into 1? It doesn't go in, so that's 0. So I can continue over here and include the 3. So this is 1, 3, which is 13. The number of times 3 goes into 13 is a 4, because 3 times 4 is 12. Subtracting that, I get a 1. And now I can bring down the 7. Now, 3 goes into 17 5 times, sorry, because 3 times 5 is 15. 17 take away 15 gives you 2. Now, bring down the next digit, which is the 3, and we now have 23. Now, 3 goes into 23 7 times, and that's 3 times 7 is 21. You subtract You get 3 take away 1, which is a 2, and now you bring down the next digit, which in this case happens to be a 0. All right. Now, 3 goes into 20 6 times. Oops, come on. 6 times, and that's 18. You subtract, you get another 2. Bring down the last digit of 0, and you'll start to notice something was happening here. We have that 1820, 1820, 1820 thing happening again. So we know that this is just going to continue as 6666 forever. Now, it says here that I've got a 13.73. We're working in money. Now, money always has 2 decimal places, as you can see. So I've got to round this number off. My final quotient, which is the answer to a divide question, I've got to round it off to 2 decimal places. Now, this 6 is 5 or greater, so that 7 has got to increase. So you have 4.58 in this case. So in this case, each person paid $4.58. Now, just as an aside, can you see a problem with this? I want you to take a look and do a little bit of quick math. You can use your calculator. Oops, sorry, that was the wrong one. Zoom page width. All right. If you did the math, you'll notice that we have a problem. 400 for $4.58 times 3 is actually $13.74. And that's because we rounded here. So someone's got to get the extra penny. What would you do in this situation? I'd steal the penny. All right? Okay. If you have any questions, review the video or come in and see me. Okay? We'll see you next time.